This is titled An Introduction to Arduino Libraries, because there's literally thousands of them. So it's just to get a feel of them. First question you might want to ask is, why? And the answer is to make your life in programming a lot easier. We're accustomed nowadays to having something like this. You just shout at a box on the wall or something that's sitting on your desk and it'll do something for you. So you can shout, Alexa, play the 1812, and it does it. You've no idea how it does it. You don't know what's inside that box, what it connects to. You don't care. All you need to know is, if I say the word Alexa and then give it an instruction to play something and give it the data, it does it. So as long as you know to use the word Alexa, the word play, and then whatever you want to have played, it works. And that's the same principle. I've just started off somebody's Alexa at home. Sorry, Gordon. So can we do the same thing in programming? For example, there, can we give a command that just says, play an MP3 file, would you? And play track number 7. And you've no idea how it does it. All you know is if you say that, it does it. That's the principle of a library, and include is to make life easier. It doesn't absorb most of your program. You still got to do all your typical coding, all your ifs and buts and ifs and elses and so on, your for loops, all your tests, all your input and output. But it gives you extra support. So what libraries do, what are they? They're basically bits of code that somebody else has written that makes life easier for you. And there's two main uses, as you'll see there. One is to handle a new device. Somebody brings out a new bit of hardware, and along with it comes a library that says, here's how to use that new bit of hardware. And as long as you know the basic commands, it'll work. And we'll look at an example of that a bit later. The other use is to improve on existing libraries. The example I've got there is a vast speed servo, which I use on the EasyBus, which improves on the standard servo library, the one that comes with the IDE. So how do libraries help? Well, it saves you work. You have an awful lot less typing to do, because all that work is, you just give one line, add that facility in, please, and it's done for you. And of course, because of that, less chances of errors, because all the work's been in that library has been tested and we know it works. So adding it in saves you lines and lines and lines of coding and possible errors along the way. Also save you researching. If somebody else has done all the hard work for you, they've worked out how to make the gadget work, how to make the lights come on or the motor move or whatever it's doing. Then let them do the heavy lifting. Because of that, you saved an awful lot of time having to figure out what to do with it, and you can then concentrate on your main program. So that's what a library is for. When you download the Arduino IDE, which is the editor and the compiler, it comes with what they call standard libraries. They're built in. You download that along with the IDE. There's an example. You can look and see what you've got. If you go up to where it says Sketch and you click there, you get a drop down and you click on Include the Library, then what you see is a list of what already exists on your machine. You don't have to specially get your way to find out how to operate a servo. It's already in the list. There's one to the stepper, already in the list. Writing to EEPROM, already in the list, and so on. So you can include these without having to take any extra steps. How do we include it? Well, two ways really, I suppose. One way is just to say so. If you're already a JAL programmer, then you'll see these commands at the top, or you've used them already. To include delay, to include random, and so on. We use these in the pocket money kits. Below it is the syntax for using it in the Arduino. So it's a hash include, and then you tell what extra library you want to add in. So if you want to handle steppers, that line has to appear in your code. If you want to handle servos, that line has to appear in your code. If you want to handle both need to appear. So you might well have 3 or 4 or 5 includes. There's no limit. Why are they called includes? Because it says there, you include them at the time you compile it. You just put in that one word, include servo. Sorry, that one sentence, include servo. And once you've included that sentence, and then you compile it, it brings in all the extra code. It's hidden from your view. It ends up in the compiled file. But it brought it in as it compiles it. It adds in the extra code. You never need to see it. The other way, again, go up to Sketch, come down to include the library. This time, instead of looking at the list, click on the word servo. And if you click on it with your mouse, then what happens is it appears in your code. Done it for you. So if it appears in the list, you can simply click it and it's added to your code. What if it's not in this list? Well, that's another issue. But how do we use a library first? Well, if you go to where it says File, Examples, you've probably used this already. There's built-in examples. And any include is in there in the examples. So there's one, for example, the liquid crystal display. Pre-written code there for you. So you can learn how to use it. You click on display, and that comes an example. You may want to use GitHub. You may want to use the manufacturers of the gadget to get more detail how to use it. But let's look at this one just as an example. You said I want to look at the display example for the liquid crystal display, and it tells you what pins to use. If you want to change them, you can, as long as you declare the differences in there. So it tells you what pins to use. It gives you an example. If you want to say the word hello world on your LCD, you just use LCD print. So you've learned something right away. Or if you want to, it doesn't have to be text. It can be a variable. Print out the value of a variable, size, temperature, whatever it happens to be. So it could be a number that's in there rather than a bit of text. And the other thing it tells you is you can display the text wherever you want. In this example, it's 0 and 1. So that tells you 1 is the second row. Everything starts at 0, as you know. So 0 will be the first row. 1 is the second row, and it starts with 0. If you want something in the middle, it would be something like 0, what would it be? 8, something like that. So it gives you examples. You can then go on to look at more complex examples and learn from other people's code. You've never used it before, but now you get the help from using the examples. Now, look at that. At the moment, as of yesterday, there was 4,838 possible libraries that Arduino knows about. There's more out there, but that's the ones that the Arduino IDE recognizes. And you can go in there and look at any one of these in the help pages of the Arduino to find out, why is there 421? Well, probably it's all kinds of different types of LCD, OLED, etc. And you can go in and find out about various sensors, some of their heat, some of their light, and so on. And then you can import that particular library. Okay, so if that library is not already in your computer, say you go in and you'd like to use one of these libraries, but it doesn't exist. How do you add a brand new library? One that's not in that drop-down list I showed you earlier. Well, what you can do, you can download the include off the internet. So the manufacturer of a new device will normally have the library for it. You download it as a zip. And the easiest way to install it is keep it as a zip. Don't try to unzip it and install it. Keep it as a zip. And you go up to Sketch, include a library, add a zip library, and it will then open up a dialog box. And you go to where that library is, davydick.zip. Click on that, and you've opened up a new library, and it adds it in. So you'll see at the bottom there, well, the standard libraries, I've just truncated it for size, but you'll see at the bottom, contributed libraries. That's ones that have been added later. They didn't come with the standard download of the IDE. I had to physically add in ones for handling steppers, for the LCD library, touch screens and so on, the DFPlayer. And I got them in simply by downloading the zip, and then go in Sketch, include library, add the zip, navigate down to the DFPlayer, for example, click on it, and it installs it. And from then on, it'll appear in that list. That's how you do it. Or the other option is to go up to Manage Libraries, and up comes a library manager. And that's for the 4,800 that it currently recognizes. It doesn't install absolutely everything when you download the IDE. That'd be crazy. But now it understands that these exist. I've just typed in a search for audio here. And it's brought up a number of audio libraries. I could pull down here and see some more. If I find one that I want, I can click install. And what happens then is that the Arduino IDE goes onto the internet, finds that library and installs it for you. So you can either go down the zip route and download the zip, or you can use that route if it's recognized by the IDE. Moving on. There's an example that we use in the DFPlayer, you'll see behind me. The DFPlayer is that little unit here. You buy it that way. You've no idea how it works inside. You don't want to know how it works inside. You want to say simple things like play track 2 or play track 5 or whatever. And all you need to know is what connections are on these pins. You don't require any knowledge of what's happening in the chips inside. And then all you have to do is connect the various pins on your Arduino to the pins in the DFPlayer. And the program can then sort it out. In this example, we've got a bunch of inputs, digital inputs. If you bring one low, that'll play track 1, that'll play track 2, that'll play track 3, track 4, etc. So it's a simple approach. And all we have to do to make all that work is to add in the word include the DFPlayer. Another example is I'm currently working on the touchscreen interface for the EasyBus controller. But it's basically a 320 by 420 resolution screen. It's using what's called SPI, a way of communicating between the Arduino and that screen, a serial interface. So because it's got an SPI interface, I've got to add in and include the handle SPI. In other words, that lets the Arduino have the ability to send out data to the screen. I also want to have this particular model of screen. So I have to include it so it knows exactly what's happening in there. But I don't want to only have text, I want to have graphics, in which case I've got to add in the graphics library. And now, just with these three alone, I'm able to put text or block diagrams or bar graphs or whatever on the screen here. I want it also to be a touch screen. So I've got to add in another include. Like I said earlier, you can have a bunch of includes to do different things. So in this case, I'm using 4 different includes. Don't need to know how the SPI works. Don't need to know how it handles the screen or the graphics or the touch screen. All I need to know is, how do I use this? In this particular case, Adafruit are the people who are supplying the libraries for this particular screen. So you can find data from them and how to use it. And luckily enough, once you've installed that library, I can go to File, Examples, go down to the library for the screen itself. And there are various, you probably start with a graphics test, which will just tell you that you have a proper connection between the Arduino and the screen. It'll print out hello world or whatever. But it's got all these, you can, once you want to learn a bit more, you can find out how it does other things. And the same would happen with the touch screen, with the graphics library, and so on. So all I need to know are, how do I use it? So in terms of writing to this screen, all I need to know is move the cursor. Remember, it's 320 by 480. So that would be 4722 in from that end. So I'm in here somewhere roughly, and I'll print the word WoSAG. I've got more control over that. I can set the type size and all that kind of stuff. But at its simplest, I can go anywhere on the screen, and I can also put in what I want to have displayed on the screen. And lastly, that was an example of using it to handle 2 bits of hardware, the DFPlayer and touchscreen. But for servos, I also said it was handy to improve on existing libraries. Well, let's take, we've got a point in a goods yard somewhere, and we want to move that horn to a particular angle. We'd like to also move it at a particular speed, slow or fast. And it'd be handy to have the ability to decide, do I want to move servo 1, wait till that's finished, and then move servo 2, wait till that's finished, then move servo 3, or can I move 1 and while it's still moving, start moving 2? You have to wait. I'd like to have that facility. We don't have that in the basic servo, the include that comes with the Arduino. If I go down again and look at the servo library that comes with it, there it is there. The main command is move the servo to that particular angle, between roughly and 180. If I want to move slowly between one and the other, I've got to say, move it to 0, move it to 1, move it to 2, move it to 3, move it to 4, move it to 5, and make 180 steps to get from one position to the other. And if I want to vary the speed, I then have to say what delay in between each step. The bigger the delay, the slower it'll take to move. But it can't have any sequencing. Whereas with the vast speed servo, it can handle the angle, it can handle the speed, and it can decide how it wants to work, all in the one command. So right to that same point, what angles you want to go to, 90, 50, whatever it is, what speed you want to move at, and then either true or false here. If it's false, it doesn't wait. So you can give that command 3 times for 3 servos, start moving the first servo, and while it's still moving, you can start the second one going, you can start the third one going. So all 3 are moving at the same time. Or if I put false in there, I have the ability to say, move servo 1, and I won't come to the next command until that's finished. And I won't come to the third command until the second one's finished. So I've got much more control over how I handle servos using var speed servo than I would with the ordinary one. So there we are, 2 reasons to use includes to support new hardware and to improve on the efficiency of existing libraries.